Thanks for tuning in for today's lecture on conversions and units. We're going to keep two rules in mind through this lecture. Number one, to always write and use units. That means numbers have a label beside them. And two, to convert measurements first. Many times we need measurements in a different unit later in the problem. For example, feet might need to be put into inches. We'll convert these before we get involved in complex mathematics. First simple problem, 85 pounds equals how many kilograms? Okay, we need pounds to go away, so I'm going to put pounds on the bottom of a fraction so that I can cancel with pounds on top. And we want kilograms to show up, both measurements of mass, so we can put them here. Now I use www.convertme.com with the high dash to look up the conversion. 1 pound is equal to 0.4536 kilograms. So this is essentially a 1. These two units, the thing on top is the same as the thing on bottom, so it's a 1, so we're not changing our measurement. 185 pounds, pounds will cancel pounds, we're left with kilograms, and we'll get the same answer simply in a different unit. And performing the math, we find 83.916 kilograms. The new Boeing 777 airplane cruises at 817 feet per second. Well, I don't really think in feet per second, so I want to know how many miles per hour that would be. When you see a P, feet per, miles per, that P always means divide. And so the way to think of this is 817 feet in actually 1 second. You can write the 1 or not, it won't matter. So the seconds are actually on the bottom, even though FPS is all on one line. So we have two conversions to perform. We need to get seconds to turn into hours, and we need to get feet to turn into miles. So I've set up two conversion bars. Seconds was on the bottom since per meant division, so I put seconds on top so that it'll cancel. Something on the top will cancel something on the bottom. And feet was on the top, so I put feet on the bottom to cancel feet, and I'll turn the feet into miles. Measure of distance, measure of time, so they both make sense. And in terms of the actual numbers, 1 hour is 3,600 seconds. There's 60 seconds in a minute, 60 minutes in an hour, and 60 times 60 gives me the 3,600. And 1 mile is 5,280 feet. Either we know that conversion or we look it up on convertme.com or any other source that you use. So seconds has canceled seconds, feet has canceled feet, and the only units left are miles on top and hours on the bottom, leaving me miles per hour. And we simply perform the math that's left in the problem. 817 times 3,600 divided by 5,280. We'll at some point need to be more careful with parentheses on top and bottom to make sure the arithmetic is correct. And the answer is 557 miles per hour, so pretty darn fast. Now, to justify the reason why I want to convert measurements early in a problem, I'm just going to take a quick look at how units work when we go into 2 and 3 dimensions. So I've drawn an example that's supposed to be 1 yard, which we can see is 3 feet. But when I go to squared, I have to draw 3 feet in one direction and 3 feet in the other, which leaves me with 9 square feet for 1 square yard. And in cubes, I'm not as good at drawing 3 dimensions, but we get the notion of 3 and 3 and then 3 coming out this way. So there's 3 rows. Each one of them is going to have 9 of these little cubes, for a total of 27 cubic feet in 1 cubic yard. Rather than have to remember 3 different conversions just for one thing here, we're going to make a big note of our rule number 2 for today's lecture, which is to convert measurements first and avoid having to deal with conversions in 2 and 3 dimensions. So for an example, here's a simple practical problem. Let's say I want to carpet my office, which is 9 feet by 11 feet, and my carpet costs $22 a square foot. Okay, we'll convert the measurements first. 9 feet, I want feet to go away and turn it into yards. Since my carpet cost is measured in square yards, so I'm going to convert everything to yards. That would be 3 yards. 11 feet, 1 yard on top and 3 feet on the bottom to cancel feet. 11 over 3 yards. You might use decimals on a calculator. It really won't matter for practical problems. And area is length times width, which we'll now use our new yard versions of those dimensions. 3 yards times 11 over 3 yards will give me 11 yards cubed. Now we have one more conversion. Sometimes we forget that this is actually conversion, but at the carpet store you can turn $22 into a square yard of carpet. So that is a conversion. We have 11 yards squared, and $22 is the same as 1 yard squared. That's what they're giving us at the store. So that cancels yards squared. It's giving me $242 for carpet. And the last problem, building a sidewalk 30 feet long, 4 inches thick, and 1 yard wide. So that's 3 dimensions. Concrete costs $85 a cubic yard. Okay, we're going to convert all 3 of our measurements. 30 feet, put feet on the bottom, yard on top. I can cancel the feet and I get 10 yards. 4 inches, okay. Can convert inches to yards, inches on top, so I put inches on the bottom and yards here. 1 yard is 36 inches. It's 3 feet and each foot is 12 inches. By the way, if you're home, if you're from anywhere that uses the metric system, which is basically anywhere except the US and Burma, you can either write these down for future reference or your conversions will be provided on test, not a memorization skill here. So the answer is 4/36 yards. You could turn this to decimal or reduce the fraction, but for our purposes in this problem, it won't really matter. 1 yard is 1 yard, so no conversion necessary. And we have all 3 dimensions now turned into yards. Volume is length times width times height. So we multiply all 3 together, keeping the units. Yard times yard times yard is yard cubed. And I get 1.1 repeating forever. In a practical problem, where we're going to actually pay money for something, then it won't really matter if we round off. We round properly to 1.11 yards cubed, and yard cubed, the conversion for that is $85, is the same as a yard cubed when you're buying concrete. So we're going to see price conversions are specific to the problem very often. And I get an answer of $94.44. Even it has its units in dollars. So to stress the 2 points from this lecture, we always write and use units throughout the problem. The numbers are never naked. They always have a unit on them. And we convert our measurements first if we're going to need them in another unit later in the problem. Good luck with your online homeworks, and feel free to send me an email or come by my office if you have any questions.